Alright, problem number 14, slowly working through this crazy long mess. Graph the hyperbola, find the coordinates of the vertices and the foci, write the equation of the asymptotes, write the equation of the hyperbola in rectangular form, factored, and write the equation in parametric form. So, first thing we should do is complete the square. I'm going to write this, I'm going to complete my x square first, so I'm going to write that as x squared minus 2x, so that's going to become x minus 1, boop, quantity squared. And then notice I have a minus 4, which I'm going to factor out from my y squared term, and I will then pull the minus, this is getting too complicated, let's just say this. Let's just go back and do all of this stuff. So if I am taking my x squared minus, I'm going to show a little more work. X squared minus 2x. To complete that square, I need to add 1. And then I can say minus 4. Let's factor out the minus 4 from my y squared. Let's factor out the minus 4 from my negative 16y. So you're left with positive 4y. And now let's complete that square. Half of 4 is 2. Squared is 4. So we get that. And that equals 19. And now I need to modify the right side, however I modified the left side. So on the left, I added the 1 to complete my x square, and I added 4 inside the parentheses to complete my y squared, so that means I actually took 4 times negative 4 out front, which means I need to subtract my 4 times 4. So minus 16 right there. So on the right there, 19 plus 1 is 20, minus 16 is 4. And so let's divide everything by 4 to get our completed square for x is x minus 1 quantity squared, but we're dividing everything by 4. So I'm going to put a 2 squared down there, minus my completed y square was a y plus 2 squared. And what's that going to be over? Well, we're dividing everything by 4, so negative 4 divided by 4 is just 1. So I'm going to put that as a 1 squared equals 4 divided by 4 is 1. So now I have my equation in factored rectangular form. I'm going to go ahead and put this into parametric form. Remember from that last problem, tangent is the negative 1, secant is the positive 1. So that tells me that tangent needs to go with y. So if I say y equals, I know it's going to be a tangent of theta. I know it's going to be a minus 2 from that positive 2 right there, and I know the coefficient out front is going to be a 1 from that 1 squared. So that tells me that x is then going to be 2 times the secant of theta plus 1, just like that. And now I have my parametric equations that represent this hyperbola. Again, x is now positive. That means that this hyperbola is horizontally oriented, which tells me that a equals 2 and b equals 1. And we need to find our foci, so let's find c. Well, remember that c squared equals a squared plus b squared. So c squared equals 4 plus 1 is 5, and so c equals the square root of 5. We see that a bunch. Since this is horizontal, that means that the x value of my center will change to give me my foci, which means my foci are going to be at the x value of my center, which I should probably state real quick. The center is going to have an x value of 1 and a y value of negative 2. Look at how that connects to the parametric form. So it's going to be the changing x value. It's going to be that 1 plus or minus my c value, the square root of 5, comma, keep the y value the same. Vertices, it's going to be the same thing. From that center, I need to go a to the left, so 1 minus 3, 1 minus 2 is negative 1. Negative 2 gives me my first vertex. My second vertex is going to be the x value of the center, which is 1, plus my a value, which is 2. So I get 3 comma negative 2. What else do I need? Equation of the asymptotes. All right. So asymptotes equation is super easy if you have your equation in rectangular form. Notice that x minus y squared and the y plus 2 squared, that's going to stay the same. So we're going to get y plus 2 equals plus or minus my slope, which we'll talk about in a moment, times my x minus 1 plucked straight out. Well, what is the slope? It's either b over a over b. Well, think about where a is going. A is with your positive term. Is your positive term x? Yes, it is, which means that a is going horizontally. So your rise is b. So b has to be 1 over your rise over your run, b over a. So 1 over 2. So 1 half right there. So there are our asymptotes. There is our rectangular. There is our parametric. There is our foci. There are our foci, and there are our vertices. What else do we need to do? Graph the hyperbola. So that's the last thing. So let's plot our center. We identified our center was at 1, -2. So there's our center right there. And again, I like parametric form because I can look at the 2 as the coefficient for my x stuff. That's telling me from x go 1, 2, and go 1, 2 that way. And the 1 in front of my tan is telling me from the center go up 1 and down 1. And now I can see my box like that. I can dash in the asymptotes which run diagonally through the corners of that box. And I know that this hyperbola is running horizontally, which means that those 2 points are going to be my vertices. And I can sketch in both branches to the best of my ability, which isn't always super great, super pretty, but there we have it. And we're super done.